Many regions have experienced a significant increase in the price of metallic conduit, particularly in the past year. There are several factors contributing to this price increase. Firstly, there has been increased demand. Due to the ongoing construction boom and supply chain disruptions, demand for metallic conduit has surged. Secondly, steel prices play a role. Metallic conduit is primarily made from steel, and the global steel industry has been experiencing high prices due to supply chain constraints and geopolitical tensions. Thirdly, transportation costs have increased. Rising fuel and transportation costs have also contributed to the increased price of materials like conduit. While steel prices have risen, the price of steel buildings has not doubled for several reasons. One factor is different market dynamics. The demand for steel buildings fluctuates more slowly compared to metallic conduit, which is used in smaller quantities and has a high turnover rate. Another factor is customizable designs. Steel buildings can be customized to meet specific needs, which allows manufacturers to optimize material usage and reduce costs. Long-term contracts also play a role. Steel building companies often negotiate long-term contracts with steel suppliers, which helps them secure more stable pricing. There are additional factors impacting conduit prices. One is local market conditions. Availability and competition within local markets can influence pricing. Another factor is wholesale versus retail purchasing. Purchasing conduit in bulk from wholesalers can result in lower prices. Also consider alternative materials. As conduit prices rise, contractors may consider alternative materials like polyvinyl chloride or flexible conduit. In conclusion, the price of metallic conduit has doubled in many areas due to increased demand, steel price fluctuations, and transportation costs. While steel prices have also risen, the market dynamics for steel buildings have prevented them from experiencing a similar price surge. Let's delve deeper into the technical aspects of conduit and steel pricing. Conduit, specifically electrical metallic tubing, or EMD, is a crucial component in electrical systems, protecting wiring from physical damage and providing a path for grounding. Its price is sensitive to fluctuations in the steel market because steel is the primary raw material. The steel used in EMT production is typically low-carbon steel, chosen for its ductility and weldability, allowing it to be easily formed into tubes. The manufacturing process involves slitting steel coils into strips, shaping them into tubes, welding the seam, and then applying a protective coating, typically zinc, for corrosion resistance. The gauge, or thickness, of the steel also impacts the price. Thicker conduit requires more material and thus costs more. When steel prices increase, the manufacturers of EMT must pass these costs on to distributors, who then pass them on to contractors and end users. The increased demand mentioned earlier is often tied to economic cycles and infrastructure projects. During periods of economic expansion, construction activity increases, driving up the demand for electrical materials like EMT. Large-scale infrastructure projects such as building new power plants, data centers, or transportation systems also require significant quantities of conduit. Supply chain disruptions, such as those caused by trade disputes, natural disasters, or global pandemics, can further exacerbate the situation. These disruptions can lead to shortages of raw materials, delays in manufacturing, and increased transportation costs, all of which contribute to higher prices. Geopolitical tensions can also impact steel prices. Tariffs or trade restrictions imposed by governments can limit the supply of steel from certain countries, leading to higher prices for domestically produced steel. The war in Ukraine, for instance, has had a significant impact on global steel markets, as Ukraine and Russia are major steel producers. Rising fuel and transportation costs affect the price of conduit in several ways. Firstly, the cost of transporting raw materials, such as steel coils, to the manufacturing plant increases. Secondly, the cost of transporting the finished conduit from the manufacturing plant to distributors and job sites also increases. These transportation costs are often passed on to the consumer in the form of higher prices. Now, let's examine why steel buildings haven't experienced the same price surge as conduit. Steel buildings are typically constructed from structural steel, which is a different type of steel than that used in EMT. Structural steel is designed for high strength and load-bearing capacity, and it is often produced in the form of I-beams, channels, and angles. While the price of structural steel is also affected by fluctuations in the steel market, there are several factors that mitigate the impact on the overall cost of steel buildings. Firstly, the demand for steel buildings is less volatile than the demand for EMT. Steel buildings are typically large, complex projects that are planned well in advance, so the demand is less susceptible to short-term fluctuations in the economy. Secondly, steel buildings are often customized to meet specific needs, which allows manufacturers to optimize material usage. Engineers can design the building to use the minimum amount of steel necessary to meet the required structural loads, reducing the overall cost. Thirdly, steel building companies often negotiate long-term contracts with steel suppliers. These contracts provide price stability, protecting them from short-term fluctuations in the steel market. These contracts help to ensure a stable supply of steel at a predictable price, allowing them to better manage their costs. Additionally, the overall cost of a steel building includes many other factors besides the cost of steel, such as design, fabrication, erection, and finishing. These costs are not directly affected by steel prices, so they can help to offset any increases in the cost of steel. Considering alternative materials for conduit is a strategic decision driven by economic factors and project requirements. Polyvinyl chloride, commonly known as polyvinyl chloride, is a plastic material often used as an alternative to metallic conduit, particularly in corrosive environments or underground applications. Polyvinyl chloride conduit is lightweight, easy to install, and resistant to chemicals and moisture, making it suitable for direct burial or exposure to harsh conditions. However, polyvinyl chloride is not as strong as steel and may not be suitable for applications where physical protection is paramount. Also, polyvinyl chloride is more susceptible to damage from ultraviolet radiation, and it may require special fittings and supports. Flexible metal conduit, often referred to as flex, is another alternative to rigid metal conduit. Flexible metal conduit is typically used in short runs or in locations where the conduit needs to be bent or moved. Flexible metal conduit is easier to install than rigid conduit, but it is not as strong and may not provide as much protection for the wiring. The choice of conduit material depends on several factors, including the environment, the type of wiring being protected, the installation requirements, and the budget. Contractors must carefully weigh the pros and cons of each material before making a decision. The National Electrical Code, or NEC, provides guidelines for the selection and installation of conduit. The NEC specifies the types of conduit that are permitted for different applications and the requirements for supporting and grounding conduit systems. Article 348 of the NEC covers electrical metallic tubing, while Article 352 covers rigid polyvinyl chloride conduit. These articles provide detailed information on the installation requirements for each type of conduit. The NEC also contains tables that specify the allowable ampacities of conductors in different types of conduit. These tables are used to determine the maximum amount of current that a conductor can carry safely without overheating. Table 310.16, for example, provides ampacity ratings for conductors in various types of conduit based on the conductor size, insulation type, and ambient temperature. When selecting conduit, it is important to consider the size of the conductors that will be installed in the conduit. The NEC specifies the maximum number of conductors that can be installed in a given size of conduit. This is to ensure that the conductors do not overheat due to overcrowding. Annex C of the NEC provides tables that list the allowable conduit fill for different types of conductors and conduit. The conduit fill is the percentage of the conduit's cross-sectional area that is occupied by the conductors. The NEC requires that the conduit fill not exceed a certain percentage to ensure adequate ventilation and prevent overheating. Grounding is another important consideration when installing conduit. The NEC requires that all metal conduit systems be properly grounded to provide a path for fault current to return to the source. This helps to protect people from electric shock and prevent damage to equipment. Article 250 of the NEC covers grounding requirements for electrical systems. The grounding conductor must be sized according to the size of the ungrounded conductors. Table 250.122 of the NEC provides guidance on the sizing of grounding conductors. The grounding conductor must be connected to a grounding electrode system such as a ground rod or metal water pipe. The grounding electrode system provides a low impedance path to ground, which helps to ensure that fault current can flow safely back to the source. In summary, the price of metallic conduit is influenced by a complex interplay of factors, including steel prices, demand, supply chain disruptions, and transportation costs. While steel building prices are also affected by steel prices, they are mitigated by factors such as different market dynamics, customizable designs, and long-term contracts. Contractors must carefully consider these factors when selecting conduit and other electrical materials to ensure that they are making the most cost-effective and safe choices. Understanding the NEC requirements for conduit installation and grounding is also essential for ensuring the safety and reliability of electrical systems. Electrical systems must meet safety requirements. Different types of conduits have different applications. Different types of steel used in construction have different properties. Steel buildings need to be grounded to reduce the risk of electrical shock and prevent damages to equipment. In order to ensure safety, one must pick the correct materials to use for the job.